All right, section 2.5. So we're looking at implicit differentiation. You're going to see that this still ties in closely with the chain rule. So what we've been doing with the chain rule, we'll need it here. All right, so first, maybe understand what this word means, implicit. So I give us two problems that we want to differentiate here. If I gave you this and I said, find the derivative, the key thing to note, if we just, I want to go through the steps technically. The key thing to note is that y is expressed explicitly, which means y is by itself. There's only one y, and it's by itself on the left. So on this problem, when it says find the derivative, it's asking for y prime or dy over dx, either one of those. That's what it's asking for, okay? But the nice thing is that it's just what we're used to. You just have one y, and it's over here on its own, okay? So the technical steps that we use, remember I said we don't really show this step, but really what we do is we're using the derivative operator. Whatever you do to the left, take the derivative of the left with respect to x, you take the derivative of the right with respect to x. So that's technically what we do, we just don't show it, but we need to know this step because y is going to be expressed differently today, and we're going to need to know what are our actual steps that we do. And then over here we say, okay, well, we'll do derivative of y with respect to x. We leave that as dy over dx, or you can also write it as y prime. So that's how we leave the left-hand side. And then, of course, the right-hand side, since it's with respect to x, you would just take the derivative, okay? Notice that the variable on the inside matches with the bottom of this derivative. This means take the derivative with respect to x. So that's our variable there. Here, notice it's derivative of y with respect to x. That's why we ended up leaving it like this and would put a y prime. So I'll go more into detail on this in just a second, okay? All right. So what's the final answer? What's the derivative of 7x minus 4? Just 7, right? So you get dy over dx equals 7. And remember, this is also, notice if I use dy over dx, it's a little bit easier to remember what it represents. Our answer represents what? What's our answer? Slope. Remember, it's the slope of it's a formula for slope of tangent lines. Just leave it cracked because it's logged. Okay. All right, so there's that. Now, I want to talk more about this operator and what we would do. So then we went into section 4 before the break, and we talked about chain rule. So we talked about if I had a problem like this, and let's say u is a function of x, okay? It's a function of x, and I said take the derivative of u cubed with respect to x. So let's think about what our answer would be. I'm trying to tie this into what we're going to be doing today. So a refresher on chain rule. Okay, so first, terminology-wise, y being expressed explicitly means y is by itself on the left. Reminder of how we do derivative. Now, refreshing on chain rule. Derivative of u cubed. Just take 2 seconds and do that, please. U is a function of x. Okay. So, what did you get for the answer now? I mean, what did you say is the derivative of u cubed with respect to x? Reason I'm saying that is because, all right, so let's think about this. So how do you do, what rule are you going to use, obviously? Power rule. So derivative of u cubed is 3u squared, but the point is this, is that since this represents a function of x, it could be like a 7x squared minus 8, or it could even be a sine of x. So you have to apply chain rule. You have to multiply by the derivative of the inside. So what should be on the very end? U prime, or you can say the derivative of the inside with respect to x, which is du over dx, but we don't write that, we would just write u prime. So my point is, notice, the variables don't match here. See, this is a u, which represents a function of x, and this is with respect to x. That's how I know that I'm going to end up with a u prime on the end. Notice over here, there's no x prime, because the derivative of x with respect to x, we just get 7. But derivative, same here, derivative of y with respect to x, we have to put it y prime. But the point I'm making is, let's say now y is a function of x, and y is not by itself. Let's say you want to do derivative with respect to x of y squared. So the same idea. U is a function of x, y is a function of x. Take the derivative of this with respect to x. So again, it's not your variable y, it's y represents something that, it could be anything with x's in it. So what should the derivative be with respect to x? So how would you normally take the derivative of y squared? 2y, but again, this is technically the inside. So you got to multiply by what? Y prime. The derivative of the inside with respect to x. That's your chain rule. This is your f prime of g, remember, and this is times your g prime of x, if you remember the chain rule. So, but instead of writing dy over dx, I can just use the symbol y prime, 2y, y prime. So anytime you take the derivative of something that's a function of x, y or u or v, but because of chain rule, you should end up with a prime on the end. Okay, if the variables match, see, like this, you say, okay, well, derivative of x squared 2x times, all right, if you want to go ahead and do derivative of the inside with respect to x, what does that end up being? Derivative of x over derivative, dx over dx is what? Dx over dx, 1. That's why you don't put anything there. Okay, this is 1. Right, because derivative of x squared with respect to x, you don't need chain rule, it's just 2x. Technically, you're multiplying by 1, but we don't put that. Okay? So here's where we're headed. All of our problems, or the majority of our problems, y is going to be expressed implicitly. Okay? So you might have a problem like this. We'll call this example 1. Find dy over dx for x squared plus y squared equals to 9. So y, in this case, is not expressed explicitly. Y is expressed implicitly, which means y is not by itself. It's not just a single y. Okay? So these are the type of problem that we're going to focus on today. Remember the problem that we worked earlier here. So you still assume that y is a function of x, that it's not, because if I was to solve for y, I could solve for y, you'd see y is a function of x. And I'll show you that in a second. So here's how we're going to do this. So we're asked to find the derivative. So what we're going to do is we're going to do the normal, like I did before on the problem. I'm going to take the derivative of the left and the derivative of the right. Notice it's with respect to x. So I'm going to take the derivative with respect to x of the left, I'm going to take the derivative with respect to x of the right. So that's the operation that I'm using because it says find derivative, find dy over dx, okay? So I'm going to go ahead and take derivative of the left and derivative of the right. And on the left, since this is a plus, I can go ahead and take the derivative of each one. So I'm going to do derivative with respect to x of x squared plus derivative with respect to x of y squared equals derivative with respect to x of 9. Okay, so now you're going to take the little discussion we just had and do the derivative for each one of these. Okay, so first of all, is everybody clear on my first steps here? That this is the operator, this means find derivative with respect to x. So I take the derivative of the left, derivative of the left, derivative of the right, and on adding and subtracting, you just take the derivative of each one. Now, if this had been a multiplication, I'd have to use product rules, okay? So luckily it's not. Now, just drop below each of those and write down the derivative. So the way you do derivative of x squared and the way you do derivative of y squared is going to be slightly different because it's with respect to x. Okay, so let's drop below each one. What's the derivative of x squared, but it's with respect to x, so what would you say? 2x. You don't need chain rule. Now, since this is derivative of y squared with respect to x, you do the derivative like you normally would, but then you got to multiply by the derivative of the inside, which is y prime. So notice, anytime the variables don't match, you should end up with a prime at the end. Okay? So when variables don't match, one's a function of the other, you should get a prime at the end, okay? Now, this is just a constant. You gotta remember what's the derivative of a constant. Oh, I think it's a horizontal line. See, 9 is a horizontal line, so what's always the slope of a horizontal line? 0. Derivative of a constant is always 0, so that's fine. All right, don't forget about that. Okay, all right, so y prime, the other symbol for y prime is what? What else did we say y prime? How's the other way you can write it? Y prime is also the same as saying what? dy over dx is the same. Those are synonymous. So if I'm solving for dy over dx, I'm solving for y prime, same idea. Now, so it says find this, so it means get y prime by itself. So look, all you're going to do now is at this point now just isolate y prime, and I'll show you what we have, okay? So isolate y prime, get y prime by itself. So that means on the right-hand side, you should have x's and y's, okay? And that's how, and I'll show you again what does that give us, what does that mean? So this is a multiplication in here, it's okay. So how would you get y prime? Isolated. Okay. So when I go to isolate, what's the first step? What would you do first? subtract 2x, okay? So we're going to get 2y times y prime equals negative 2x. And then, since it's 2y times y prime, I'm going to divide both sides by 2y. And I get y prime equals, the 2's cancel, negative x over y. So it's a little weird that we have an x on the right-hand side, but it's okay. Don't forget what this stands for. Y prime, or dy over dx, the derivative stands for what? What does this stand for? Slope of tangent line. Guys, if I go to your house at 2 a.m. and I knock on your door like I'm trick-or-treating, and you're half asleep, and I said, what's the derivative? Slope of tangent line. Formula for slope of tangent line, technically, right? You gotta just, like a robot, just gotta memorize that formula, right? It's a formula for the slope of the tangent line. So what I went ahead is I drew this. What's this? It's the graph. X squared plus y squared equals to 9 is a circle centered at the origin. Radius is 3. So I want to show you that now I don't need, normally we would just need an x and we could get the slope. Now you need the point. If you know the coordinate, if you know the point on the graph, plug in your x, plug in your y, it should tell us slope. So for instance, like right here, this is the point 3, 0. So if I draw a tangent line here, notice my tangent line is what? What type of line is it? Vertical. What's the slope of a vertical line? Undefined. So it should make sense. We should get undefined. So let's see. So if I do y prime of 3 comma 0, and when you have more than one variable, instead of you put a parenthesis in there like this. So this means that y prime is in terms of x and y. So it would be negative 3 over 0, which is undefined. Correct. That makes sense. Okay, let's see, if I go over here, 0, 3, what's the slope there? At 0, 3. 0, so let's see, if I do y prime of 0, 3, that means I plug in a 0 for x and a 3 for y, negative 0 over 3 is 0. All right, there's that. If I were to pick something here in the second quadrant, so let's say it's negative 1 square root of 8 should be in the second quadrant. It's not the previous, but I know that's there. So let's see, that slope should be what type of slope? Positive or negative? Positive, okay? All right, so let's see. Is that right? So if I plug in y prime of negative 1 square root of 8, negative 1 over square root of 8, and I get positive 1 over square root of 8. Okay. So the key thing to see is that your answer may be in terms of x and y. You may have more than one, just an x on that side. So let's go through the steps again. Okay. This is a typical type of problem that we've had. So notice y is not by itself, so we say it's expressed implicitly. I take the derivative of each piece, okay? And I know that anytime I take the derivative of a y with respect to x, I should end up with a y prime. Anytime I take the derivative of x with respect to x, it's just the normal rule. Okay, I don't need chain rule. Derivative of a constant is always 0. And then my last step was, since it said find dy over dx, I got what solve for y prime by itself. Okay? All right. There's one problem. Let's do another one. Okay? But that's the process. Now I'm going to give you kind of a step-by-step on how I work these, because this next problem's a little bit more detailed. So I'll kind of go through in steps how I work it. Notice here, there would be no way to get a y by itself because you have three y's. You have a y cubed, a y squared, and a y. So y is definitely expressed implicitly. So we're going to find dy over dx. So let me go through our steps. So first step is take derivative with respect to x of both sides. So that's my first step that I'm going to do. So as we work this problem, I'll give you my steps for implicit differentiation, okay? All right, so that's the first step I'll do. Take the derivative of both sides with respect to x. And then you can go term by term, right? So pluses and minuses, you can take it of each term. So first step should be derivative with respect to x of the left. Oops. Equals derivative with respect to x of the right. All right. Then the next thing is you can take derivative with respect to x of each term, right? If it's adding and subtracting, you can split it up. So you should actually have 4 derivatives on the left. Step 3, remember to apply chain rule when variables don't match, when it's not the same variable. So if you're taking derivative of something with a y, you should get a y prime at the end. Okay? You should get a y prime. Anytime you're taking derivative of a y with respect to x, you should pick up a y prime. And if something is going to happen, you should get more than one y prime. And then I'll show you how we deal with that. Okay? How many y primes should you get? 3. There's 3 y's. Each one should give you a y prime when you differentiate with respect to x. So if I follow step 2, take the derivative with respect to x of each term. So term by term. Terms are separated by pluses and minuses. So I take the derivative with respect to x of each term. The right hand side is still the derivative of -4. Okay. And I'll show you kind of how I think about it. All right, what I do. Okay, so let's do the first one. Derivative of y cubed with respect to x should be what? So here's what I tell myself. I say, okay, if the variables are not the same here, I know I gotta put a prime at the end. So it's gonna be 3y squared, chain rule times y prime. Right here, derivative of y squared, we already did that one, 2y times y prime. Now, this is the one that may get students sometime. So look, you can look at it like this, if this helps. Well, first of all, does somebody want to give me the answer? What did you get? There's 5 times y prime. Here's how I would look at it. See, the 5, you can move in front because it's multiplied. Now you got dy over dx, 5y prime. Or just, I always kind of tell myself, students, you know, had this been 5x, you would have just said 5. Right? Since it's 5y, you're going to say 5, and always you're multiplying by y prime on the end. 5y prime. Okay. But see what I said, you could have moved that 5 in front, and then it's just 5 times dy over dx, 5 times y prime. Minus, what's the derivative of x squared? 2x. And then the derivative of -4 on the right is 0. Okay. The problem is we need to solve for y prime, right? We need to, do r dx, which is the same as y prime. So we need to solve for y prime. Now, here's what I do. So if I'm going to solve for y prime, the first thing I do is get all y primes on one side. So I make sure all the y primes are on one side, everything else is on the other. So that stays, that stays, that stays. This minus 2x I'm going to move over. I'm going to move it to the other side. So I have 3y squared y prime plus 2y y prime minus 5y prime equals 2x. Because all I'm doing is adding 2x to both sides and it moves over. Now everything on the left should have a y prime in it. So I'll say that again. Every term on the left has a y prime, which means every term on the left has a common factor. The common factor for every term on the left is what? Y prime. Very good. So how can you turn 3 y primes into 1 y prime? You factor it out. See, we don't want it. We got to get it by itself. We got to solve for it, right? So what I'm going to do here, the next step is, once I get all y primes on one side, I can factor out y prime, and those 3 y primes now turn into 1. So I can say 3y squared plus 2y minus 5 times y prime is 2x. And then the last step is now, how do I solve for y prime? Well, I'll have to use division. There's the answer. That's your y prime. All right? And those are the steps. So solve for y prime. Get all y prime on one side, factor out y prime. Now isolate y prime, usually by division is what's going to happen if you factor it out. Okay? And those are the steps that I use when I'm taking the derivative implicitly. We'll do another problem, and not too bad. I won't make it too crazy just yet. We'll do one more. All right, one more problem, and then we'll go to the next level. Okay, I'll leave those steps there. Can I erase this problem? You guys have it? Okay. All right, so example 3. So now I'm going to just let you go, then we'll check your work, and then we'll go to a tougher problem. All right, go ahead and work that one. It won't always have a constant on the right, but most of them do. change this one to 7y, 7x. I'm assuming you haven't done that before yet. I changed example 4, make it a little tougher. I've kept the All right, let's check our work on example 3. So the first thing I'm going to do is take the derivative of each term. So I'm not going to take just the derivative of the whole left. I'm going to go ahead and split it up into 2 derivatives. All right, so there's that. So I'm going to go through and find each derivative separately. So derivative of 2x cubed, you should get what? 6x squared. Derivative of 3y cubed with respect to x.
9y squared times 5.
Yeah, and then the derivative of 64 goes to 0. So what's nice about this one, you only back to the basic, there's only one y prime. Then I just move everything over. So I move the 6x squared over, so 9y squared, y prime is negative 6x squared. Divide by, wait, I feel like I've done something wrong. Nope. Divide by 9y squared. Now, the one thing I would do is reduce this fraction. So instead of saying negative 6x squared over y squared, I would say y prime is negative 2x squared over 3y squared, because you can take a 3 out. Okay? All right. Now, let's at least talk about, all right, any questions on that? So we went to a standard problem there. Okay? Notice I didn't have to worry about factoring out a y prime because I only had one y prime. Here I picked one that you're going to have more than one y prime. So 3 terms. This is considered one term because it's multiplication. So my first step, I'll take the derivative of each term. So it's going to be the derivative of x squared y cubed. I can't, that's multiplied. So I got to look at that together. And I have to apply a rule to that. Minus the derivative with respect to x of 7y equals the derivative with respect to x of 12x. So the second 2 should be easy, right? This should be easy derivative, 7y, and the 12x should be easy. But the question is, how am I going to do derivative of x squared times y cubed? Because it's multiplication. Well, what rule do you have to use anytime there's multiplication of functions? Product rule. So what I'm going to do is I'm going to drop down and call that u and call the y cubed v. So x squared is u, y cubed is v, and I'm going to write my power rule out, or my product rule out. So I'll just write that it's u prime v plus v prime u. Then minus, I already know what that is, equals that. So these 2, I can go ahead and take those derivatives and put them there. Now I need to go to the side and to find u prime and v prime, again, with respect to x. So I got to find each of these derivatives with respect to x, and then I'll plug those in. So I'll go to the side. U is x squared, what's u prime with respect to x? V is y cubed, what's v prime with respect to x? And then, I'm sorry, yeah, with respect to it, and just shove those in, okay? You basically have 3 blanks. The product rule, derivative of 7y, and the derivative of 12x, all with respect to x. This is the equals. So then if you fill in those blanks, then now you're at step 4, where you solve for y prime. Are we done at 9:20 today? Does that sound right on a 7-period day? We may do one or two more, and then kind of stop there. We're done at 9:20, so I'll probably do one more that's a little different. Oops, I ran out of room over here. Just erase, I'm gonna erase these steps. I think we got them by now. Okay. So on that, we said u is x squared, v is y cubed. So what did you get for u prime? 2x. What do you get for v prime? 3y squared times y prime. You got to use chain rule because it's with respect to x. Then I sub everything in. So u prime is 2x, v is y cubed, plus v prime, 3y squared y prime, times u, which is x squared, minus derivative of 7y is 7y prime, and derivative of 12x is 12. All right. Then what was the next step? And I'll tell you this, I usually do x then y when I'm multiplying x then y prime. So for instance, on this one, I'm going to change it here in a second. 3x squared y prime. Okay. All right. What was the next step in your steps there? After you differentiate, you got to do what?
Isolate the y prime.
Yeah, so keep the y prime terms on the left, move everything else to the right. So this 2xy cubed will go over. So I have 3x squared y prime minus 7y prime equals 12 minus 2xy cubed. Okay? And the reason I did that is so that now all I'm left are terms that have y prime in it, and then I can do what with these two y primes? It was the last, yeah. So if you go step by step, now you factor out the y primes, 3x squared y squared minus 7. And now that last operation that you have to do is division, and division will allow me to isolate y prime. So let's see. So Brewski, this final thing that you've come up with graphically represents what?
I'm not so sure.
So again, if I come to your house at 2 a.m. And I knock on your door and I ask you, what does derivative stand for? You're going to say a formula for the slope of the tangent line. Always go back to the simplicity of it. Don't get caught up in this. When you look at all that, just remember, derivative, if we're talking, what does it represent? It's graphically, it's the formula. Well, we need an x and a y, then we'll get the slope of the tangent line, okay? So it's a formula for slope of tangent line. So all this, through all this madness, I don't want you to lose sight of what you're finding. But now in order to get slope, you need an x and a y. You can't just plug in an x. That's what's different. So when y is expressed implicitly, typically you'll get x's and y's on the right. So you need a whole point. And they'll say, use this point to get the slope. So you'll be answering those questions. I don't know a point on this graph off the top of my head. Maybe I could say when x is 1, we could solve for y, but it wouldn't be very pretty. So, but that's it. Now, the last one I want to look at, because we're running low on time, is the transcendental functions. Don't forget how you would do those implicitly. So let's say our last example, let's say we had example 5 here. Let's say we have e to the y minus sine of 7y equals x squared. All right, let's say that that's what we have, okay? No, the good news is there's no what rules on the board like you had on the last one, no what. No product rule. But you should have chain rule, no chain rule. So find dy over dx, go. See if you can do this one. I'm probably gonna work this one a little in here in a second because I'm running low on film. I don't like my distance is going too long. Okay, let's go through each of these derivatives. All right, what's the derivative of e to the y with respect to x? So you do the derivative like you normally would, e to the y, but then you got to multiply by the derivative of the inside. What's the derivative of y? Y prime, very good. Minus sine of 7y, so what's the derivative of sine? Cosine of 7y, but again, since there's a function of x on the inside and y is a function of x, you got to multiply by the derivative. So what's the derivative of 7y? 7y prime. Remember, anytime you take derivative with a y, you should get, with respect to x, you should get a y prime on the end. Equals, then what's the derivative of x squared with respect to x? 2x. All right. And now your y primes are already over there by themselves. So now all you gotta do is factor out a y prime. I would move this 7 in front of the cosine, but I'll factor a y prime out and I get e to the y minus 7 cosine of 7y equals 2x. And I'll divide by e to the y minus 7 cosine of y, or cosine of 7y, sorry. And I get this answer. And this is my y prime. Everybody okay with that? I'll factor the y prime out. And then whatever I'm left with, I went ahead and moved this 7 in front of the cosine. And there you go. Naomi, what does our answer stand for? Yeah, it gives the slope of a tangent. Just give us an x and a y. Okay? So I'm neglecting that part about plugging in. I'm just trying to get you going. We'll do part 2 on Wednesday, but this should get you going. I would work on the JIT that should be in there, and then you have this, okay? All right. I'm going to stop that.